that will be showcasing how hybrid quantum algorithms, blending classical and quantum approaches, are already solving real business problems in logistics, energy, and finance. And as you may see, we are going to have a shared presentation by two speakers. Please welcome Eva Narunovska, the CEO and co-founder of Force AI. Welcome, Eva. And Maksims Dimitrievs, docent and researcher at the University of Latvia. Very warm welcome, and the screen and floor is yours.
Hello, everyone. I'm honestly honored to be here with Latvian quantum scientists. And today we will tell you about hybrid quantum algorithms for real-world business decision-making. Actually, I'm working with data-driven decisions for business all my professional lifetime. So more than 20 years ago, I was actually coding these SQL queries, generating summary reports for business strategic meetings. Lots of things have changed ever since. What I can see mainly is that there are a lot more data amounts that the businesses are looking through for their decision making. And a few years ago, a super cool thing was all those charts and dashboards for business decisions. Then now you can see that business owners and decision makers are getting lost if they look through all those charts and try to understand patterns among those and make smart decisions. They still need to use their intuition. So that's why we built Force AI, using all our experience for really wise decision makings looking into future. So this is about predictive analytics, decision making, and also prescriptive analytics. So the tool is actually telling the business managers what to do, how to increase sales and revenues. Technically, we are using traditional machine learning. So it is data science and also large language models on top of that, so that our clients can actually talk to the data without being data scientists, and the tool will actually communicate with this predictive analytics. So it's about probability calculation for lead conversion, so you can prioritize leads and even know why those leads have to be prioritized to be converted. It's about churn prediction and timely communicating with clients who could leave you, because we can identify reasons why those clients or each client could leave you. It's about ideal customer profile and most beneficial activities for sales increase, like pricing, product offering, marketing channels, and so on.
So, as you can see here, I believe that education is the key. In 2013, I attended lectures led by Professor Andris Ambainis. This was my very first experience with quantum computation. Then I was just studying some different stuff. In 2018 and 19, I was honored to start to learn about quantum programming. And I was among the first who actually started to develop quantum programming courses that later became part of the Q world. And so it's interesting that our idea was just to learn what it does, how we can use this quantum programming, eventually develop materials, and while educating, we were learning. And this widened our opportunities. So now in University of Latvia, we also developed quantum study modules. And yeah, currently I'm teaching some quantum courses about practical programming. And each time where there appears an opportunity to learn something, it's actually good to combine it both with practical part, with new areas, and as a result, we can even try to collaborate with industry. And this is, let's say, my very first experience to collaborate with industry, and I learned again some new stuff.
Mm-hmm. So why did we decide to make first steps with quantum for business? As I already mentioned, data amounts are growing very rapidly. And last years, the demand for data scientists is growing 4 times each year. But it's not just about data scientists, it's actually about data usage, additional data variables, because business owners already start understanding the benefits of AI solutions. And they understand the more data they have, the more they keep track of, the better AI solutions they will get. So they're starting to register more and more info. They're gradually growing each day, and they start to integrate more and more. Like our Force AI solution is looking through Google Analytics, social networks, CRM systems, sales data, accounting data, and can integrate various data sources for smart AI solutions. So now we are seeing another issue that classical AI solutions are about to reach their limits in optimizing complex algorithms for predictive analytics. So that's where we see quantum opportunity for business. Enhancing classical AI with quantum can unlock new opportunities in case you want to put really smart algorithms for smart business, data-driven business decisions. So as I already mentioned, we are working with classical AI, traditional machine learning for predictive analytics, and then you know our main benefits of quantum solution, which is of course the speed. But we are not proposing to replace classical AI with quantum. We are proposing to enhance classical AI with quantum by developing hybrid AI solution. We actually did first work already, so we have first research work done in a team with Maxims and a few more scientists in Latvian University led by Andris Ambainis. And we decided to look into data series forecasting. We actually already did have this classical AI solution for time series forecasting because it is actual for every business industry. It's not just about finance, retail, wholesale. Any business wants to see how their demand will grow in future, how their sales will increase or decrease, revenues, or just the units of the product, because then you can actually plan what you need and when. So the time series allows you to look through future data. For example, here in example, there is a blue line represents historical data of the company that gets analyzed, and the yellow or orange line is a future prediction taking in account time and other factors that could influence this. So if you develop it further, you can actually play this scenario for various business decisions like price change, another marketing channel usage, or so on. And then you can see at what time or which specific days or months of the year how this demand will change. So now I will let Maxims to speak more about actual work what was done, because he was one of those who was actually coding all that solution, and he will be better in telling all the technical details.
I will try to not be too technical. So here, if you think about how to look at this diagram, you can try to look at it in zigzag way, so going from up to down, then up again, up, down. So this is what we focused on, so time series forecasting. You have seen previous slide, and next slide you'll have even more details about it. But if we want to involve quantum computation, you already heard from previous two talks, there are some challenges. Capacity is limited. We also should learn actually how to pass classical data to a quantum computer efficiently and then to process it and obtain meaningful results. So hybrid quantum algorithms is one of the possibilities, because then we can enhance both classical and quantum computation with their interaction, so that we can at least limit the necessity of quantum resources, so we can save some and maybe use already available quantum devices. And since we can use quantum devices and they may provide some opportunities, then opportunities also for business. So hopefully we'll get some useful results also to get some business value. And to ensure that it is possible, of course, we should test on real-world data and on real-world problems. So time series, you have seen the previous slide. Now imagine that we are given a list of data where you have data points for some specific time moments. Here you see a graph which is generated synthetically, like from real-world data on which we later tried our experiments. So we have data point for each month, amount of sales volume in millions of euro. And we get some data from the past. We want to predict future. So in order to pass it to quantum devices for machine learning tasks, we needed first to differentiate it, how it works. We just save, instead of like exact values, we save the difference compared to the previous result. So, for example, first point is 0, it's beginning, then next point goes down, so it will be negative value, then goes up positive value, and so on. So we actually see the dynamics, not the exact values when we are passing this. And then what we want to see, how much will differ the next data point from previous one. And so this information is also enough to predict future in the end. We also needed to normalize data, of course, to fit them into qubits, because state 0 and state 1, so you have values between 0 and 1. And we tried it with two approaches. The first one is called parameterized quantum circuit. So here you can see we tried parameterized quantum circuit with two different classical optimizers and compared results with two classical approaches. So in case of classical neural network, we had also like 12 elements in 2 layers, and ReLU activation function was used. This was just to mimic the quantum limitations, to see like if we have similar amount of classical resources, what would be the difference. So here, this quantum circuit, what it represents, laser actually working, but you will not see. The first column, you see there is zeros, so it's just beginning of the quantum circuit. Then there follows a column of boxes. This is initialization of input data. And then the remaining part are actually parameterized quantum gates, our quantum circuit, in other words, ansatz, that we try to tune up so that after receiving this input data, it produces output that could be our prediction for the future values of our time series. And what we can see here, despite the fact that our parameterized quantum circuit had bigger mean square error in training data, it actually obtained quite good results in test set. One of the reasons could be overfitting of classical models, but still it shows a good sign that actually quantum approach here could work efficiently. One more thing is, as many data points you have, as many qubits are needed with such approach. It's possible to have fewer qubits. We tried the second approach, which is variational quantum linear regression. So here we implemented a variational quantum linear solver. What you can see on the top right part is a transformation that implements vector matrix multiplication. So basically we multiply vector bar matrix, and we want to compare it with another vector and see how much the states are different. To see the difference, we use Hadamard test, which you can see on the top left side. So basically, this huge transformation is controlled by 1 qubit between 2 Hadamards. And this small matrices P in our transformation U, those are our parameters that we feed in of our past data. Then this vector B is our next step of future data, and ansatz then tries to have this good prediction, and then later this ansatz can be used for upcoming data and still try to predict the future. And here you can see ansatz for 2 qubits, which means time series of 4 input data elements. So here it scales better in terms of number of qubits. So square root is the number of qubits that we need. So this one can be really suitable for NISQ devices. Moreover, in each run we launch actually multiple different quantum circuits because we launch them for different PI matrices, which is just Pauli gates with some parameters. As a result, we have a lots of but small quantum circuits, which is exactly in the style of NISQ era solutions. So yeah, you have heard a lot about challenges. I want here to summarize a bit idea about the challenges. So my opinion, also if I would look from investor perspective, it's really good to move from all directions simultaneously. So one part is academia and also engineering in general, where we have to develop hardware as well as more efficient quantum algorithms. So we try to compensate the fact that we are still in NISQ era, try to either get as much as we can from existing resources or try to increase these resources. At the same time, we need skilled people. So this is what I believe in, and being one of the co-founders of QWorld, I can say that it's really good to see that people are interested to get the skills, but we need to motivate them. How we motivate them? We need to provide them means of living, so how to earn with it, or how to make some impact on the world that will make lives of people around you better. And this is where businesses come. So, of course, challenge there is how to evaluate the cost versus the obtained business value. Currently, we don't have too many business cases with long history to actually use this as our time series of past data to predict the future potential impact if you try to launch some incentives with existing quantum hardware. Not to mention that still the future is not so known. We are not sure how well the future quantum capacities will grow up. So this is what I'm saying. It's good to move from all three directions. Develop better devices and algorithms, prepare people to be skilled, at least to not be ignorant in this area. So now, for most people, I guess quantum is not something mystic as it was maybe a few years ago. And at the same time, businesses can encourage people to show that actually your knowledge can be either monetized or transformed into some everyday life solutions for people. And now I pass to Eva.
Thank you. Yeah, so as I mentioned, there are lots of benefits of quantum usage for various areas in predictive analytics. Of course, it's about sales and revenue increase, but also you can use it for fraud prediction, for optimizing processes in business, and as I mentioned, it could actually be interesting for any business industry. And on my opinion, early adoption means competitive edge for businesses. So for SAYA vision is quantum-enhanced business intelligence, wise decisions for business leadership taking in a rapid manner. So what would be the right time to invest? Currently, we all know that quantum hardware is not yet mature enough to give all the benefits today. However, once it becomes ready, whether it is 5 or 7 years from now, without quantum algorithms, you will not be able to use all these advantages. So those who will be there first in business, they will take the leadership positions. The other ones will actually lose competitive advantage. So that's why I would say that the right time to invest is now, because it takes time to build infrastructure, to build algorithms, and to cooperate with the teams. And how to do that? We actually got very good experience with working together with Latvian University quantum scientists. It was honestly a pleasure. So I would recommend the same, to find the teams that could develop hybrid quantum solutions for your business, start with experiments, focus on areas that are not critical, but at the same time have big impact in future. So quantum is not just a dream, it's a tool. And it's not in a distant future. It's a strategic edge waiting to be explored, and it gives lots of business opportunities. Thank you. We're ready for questions, I guess.
Thank you.
Thank you.